I'm going to be doing the word equations on page 41. I picked 2 to do for you guys. I picked number 1, and then I also picked number 6. So these will be freebies if you guys watch this video. And it's good for helping, obviously, learn how to do the rest of the page. So this one, you have to absolutely know chapter 9 in order to write the word equations, right? So first of all, I'm going to do number 1. So here it says zinc, which I know is Zn, and again, I'm looking at, whenever I'm filling all this out, I'm looking at my periodic table if I don't know the names of them or the abbreviations of the elements. I'm also looking chapter 9 at my oxidation numbers on that periodic table in chapter 9 that has all the oxidation numbers. I'm also looking at those oxyanion charts from chapter 9, lots of things from chapter 9, okay? So I've got zinc, and it says it is going to mix with lead 2 nitrate. All right, so lead 2, so Roman numeral 2, that is the stock system. So lead is Pb. I'm going to come over here just so I can figure out what lead 2 nitrate actually is, then I'll write it in my equation. So I've got Pb. Remember, the Roman numeral 2 tells me the oxidation number, right? And I have to write these correctly whenever I'm building my word equations so that I can balance them. Because if they're not written correctly, you're never going to be able to balance them, or the balancing just won't be correct. And then nitrate. So if I look at my oxyanion chart in chapter 9, I'll see that nitrate is NO3. And that NO3 has a -1 oxidation number, okay? And then whenever I use the crisscross method, I'm going to take the absolute value of the oxidation number, and I'm going to assign it as the subscript for each one of these, right? So anytime I've got a polyatomic ion, I'm going to put it in parentheses if there's more than one of those, okay? So I'm going to have 1 lead and 2 nitrates. And I don't write the 1 whenever I'm actually writing my, my molecule. So I've got lead, and then I've got nitrate, okay? And then it says it yields zinc nitrate. So I know I've got zinc, and again, I'm going to come down here and write my molecule so that I can look at it a little closer. Nitrite, I've already looked at that, right? And that was NO3, and it's got a -1 oxidation number. If I look at my oxidation numbers on the periodic table, zinc is going to have a +2, okay? So whenever I crisscross that, I'm going to have 1 zinc, remember it's the absolute value, and since I've got more than 1 nitrate, I'm going to put it in parentheses and add the 2 there. I'm going to bring that 2 down there. So it's going to be zinc, 1 of those, and then nitrate, 2 of those. And it yields lead. Okay, so now I'm going to look at balancing, okay? I've got 1 zinc here, 1 zinc here, got 1 lead here, 1 lead here. Wait, and I've got 6 oxygens, 6 oxygens, 2 nitrogens, 2 nitrogens. It's already balanced. I don't have to do anything else. Awesome. So this right here is the word equation for number 1. Zinc plus lead 2 nitrate yields zinc nitrate and lead. So if I'm looking at this too, I'm going to wonder, what kind of a reaction is this? It is a single replacement, because I'm taking this zinc and I am replacing lead, right? I just kind of took it away and I replaced it. And you would look at that chart on page, actually I don't know the page, but in chapter 10 where it has the reactivity chart, and this would happen, it would occur if zinc was more reactive than lead, if it was higher on that chart than lead actually is. All right, we're going to do the next one, and this one is number 6. So I've got calcium hydroxide. So again, I'm going to write this down here a little bit so that I can see what it is before I write it. So I've got calcium, and I know calcium has a +2 oxidation number based on that chart. Hydroxide is one of my oxyanions. It's OH, and it has a -1 oxidation number. So if I do the crisscross method, I'm going to have 1 calciums and 2 hydroxides, right? I'm going to take the oxidation number, absolute value, and I'm going to crisscross that. So up here, I'm going to have calcium hydroxide and phosphoric acid, okay? So I'm looking at this. It doesn't say hydro, so it's not binary. It's a ternary acid, right? It ends in ic. So that means that whenever I'm looking at the chart, I'm going to find what? Phosphorate, right? Or phosphate, I should say. I'm sorry, phosphate. Phosphate, because ate turns to ic whenever you're making an acid, okay? So whenever I'm finding phosphate, it is PO4, okay? So it's an acid, so it's going to start with hydrogen, right? And it's PO4. But then I have to balance that out, okay? What was the oxidation value of PO4? It was -3, and hydrogens is a +1. So if I crisscross that absolute value, I'm going to have 3 hydrogens and 1 phosphate. Okay? So then it yields calcium phosphate. Calcium, and I already know that phosphate is right here. So then, again, I've got to look at oxidation numbers. What was my oxidation number of phosphate? It was -3. Oxidation number of calcium is +2. So I'm going to crisscross absolute value. I've got 3 calciums, and then I have 2 phosphates. So it yields calcium phosphate and water. I'm going to put that down here. And water, which we know is H2O. Okay? So then, first of all, this is a double replacement, guys. Okay? Because my calcium and hydrogen are basically swapping, right? This calcium is now with the phosphate, and then this hydrogen is now with the hydroxides, and it's making water. Okay? And remember, one of the 3 things that you need possibly to make a double replacement, you need one of the 3 things, was water. And then here's water, so yes, this would be a double replacement. Okay, so I need to balance this now. I know it's not balanced. I've got calcium, I've got 3 over here, I've got 1 over here. Okay? So I've got, can you guys see me? Yeah. All right, so calcium, I have 1 over here, I have 3 over here. Oxygens, I've got 2 plus 4 is 6 over here. Oxygens, I have 8 here, plus 1 here is 9. And then I also have hydrogen. I've got 2 here, plus 3 here is 5. And then, making sure you guys can still see me. Hydrogens over here, I only have 2. And then I also have phosphorus. Can you still see that? Yeah. I've got 1 phosphorus over here, and I've got 2 phosphoruses over here. Okay, so we're going to have to play around with this a little bit. All right, an easy one, phosphorus. I've got 1 over here and 2 over here, right? So I'm going to put a 2 here to even out my phosphoruses, right? So now I have 2 phosphoruses, okay? Those are done. But that changes my number of hydrogens, right? Because that was in here. So I've got 6 here, and I have 2 here. So now I have 8 hydrogens over here. And it also changes my number of oxygens, right? I've got 2 phosphoric acids, so that means there's 4 in it. So I've got 4 times 2 is 8. 8 plus these 2 is 10. So now I have 10 of those. Okay. So what's another easy thing I can do? There's no hydrogen up here. Let's see. So that's kind of good. Let's see here. So this this one might be an easy one, right? Calcium. I've got 3 here, I definitely need 3 here, right? So I'll make this a 3. Got 3 calciums, but again, it changes my oxygen and hydrogens. So I've got 2 of them here, so 3 times 2 is 6. So I've got 6 oxygens over here. And then over here, I have 2 times 4 is 8, so I have 8 oxygens over here. So 6 plus 8 is 14. So I've got 14 oxygens now over here. And it also changes my hydrogens. 3 times 2 is 6 hydrogens over here. And I have 6 hydrogens over here, which tells me I now have 12 hydrogens. Okay, so looking over here, my oxygens are quite wonky. I've got 9 here and 14. Hydrogens, I can work with this, right? I've got 2 and 12. If I put a 6 here, that can equal those. 6 times 2 is 12. Sweet. So now that changes my oxygen. So I've got 4 times 2 is 8. So I've got 8 oxygens here plus 6 is 14. Yahoo! So I'm even now, right? So this is the answer to number 6. All right, all balanced out.